Hello, good afternoon, algebra students. So, here are your notes for 1-3, translating algebraic expressions. Hopefully, this is a little familiar because we did talk about this last year. My hair looks really bad, don't look at it. Okay, so translating. First thing, just like we wrote down last year, is when you're translating anything, they're giving you sentences. So, it's really important that you're reading carefully and that you're doing it multiple times. You should never only be reading a problem once. You should always be reading your problems multiple times. And the next little bullet point that we're going to talk about to remember or to keep in mind is that you need to be careful with those subtraction problems. So what I mean by that is those problems when it says something like 9 less than 2. Does that look like 9 minus 2 or 2 minus 9? So you have to read it. 9 less than 2 means that I want to take 9 away from 2. So that would translate to the expression 2 minus 9. You might automatically think that it's 9 minus 2 because the 9 is coming first, but that's what you need to watch out for. It's 2 taking away 9. Okay, so looking at the first example. 2 less than, so that's just like that subtraction piece we just talked about, 2 less than 1/4 of n raised to the second power. So there's a couple of things going on here. 2 less, we know that is that minus 2, 2 less than something, just like 9 less than something up here gave us minus 9. 2 less than 1/4 of means multiplication, ULT, and then raised to the second power is an exponent of 2, like caret 2. So first 1/4 of n could be in parentheses, keeping in mind that n is being raised to the second power, and then we want 2 less than that. So that gives us the expression 1/4 n squared minus 2. Look in example 3. 3/4 of the difference between y and 8. So first thing I'm noticing, 3/4, 3/4 of, again, that of is multiplication. When they're talking about a fraction of something, that's multiplication. So 3/4 of the difference, we know that difference is subtraction between y and 8. So that's y minus 8. So 3/4 of the difference between y and 8. So before I take 3/4 of anything, I need to start with that difference of y and 8. So we've got y minus 8 for the difference between y and 8, and then we want to take 3/4 of that. Now be careful here. If you just put the 3/4 outside next to the y, you're only multiplying it by the y and not by both pieces. To show that you're multiplying it by both pieces, you just need to go ahead and put those parentheses around both things there. And there's example 2. Example 3. If y is an even number, write an expression to represent the sum of the next 2 consecutive even integers. So we have some vocab here. So maybe you're remembering this stuff from last year, maybe you're not. Consecutive. Remember, you go to school, now you only go to school for 2 consecutive days in a row. So that consecutive is in a row. Even, that's 2, 4, 6, 8, 0, those numbers. And integers are positive and negative whole numbers. So whenever you get a problem that starts talking about odd or even numbers, always use one as an example. So I'm going to pick 2 as the even number that I'm looking at. Write an expression to represent the sum means addition, of the next 2 consecutive even integers. So if 2 is the number I'm starting with, the next consecutive even integer after that would be 4, followed by 6. So what do I need to do to 4? Or sorry, to 2. What do I need to do to 2 in order to get it to 4? 2 plus what gives me 4? 2. So x plus 2 would get me the next consecutive integer. And then what do I need to do to 4? What do I need to do to 2 to get to 6 now? Instead of adding 2, we're going to add 4. So these are the next two numbers. And the sum of them would just look like adding them together. X plus 2 plus x plus 4. Which you could simplify if you wanted to, down to 2x plus 6. All right, one last example. Tim, Joe, and Bob all collect classic cars. Joe has 4 less than twice as many cars as Tim, and Bob has 6 more cars than Tim does. Altogether, they have 9 more than 3 times as many cars as Tim, blah, blah, blah. Key point here is that 1, you're writing an expression for each person. So that's the kind of stuff where we come off to the side and we start with Tim equals, Joe equals, and Bob equals. And set up the equation. You do not have to solve it. So we're just figuring this out here. Now, you're looking for the person who has the least amount of information first to be your plain old X. Joe has 4 less than twice as many cars as Tim. So this sentence is talking about Joe. Bob has 6 more. This one's talking about Bob. So the only one we don't have any information about right now is Tim, which means Tim has to be our X. So Joe has 4 less than twice as many cars as Tim. Twice as many cars as Tim is 2x, twice as many times 2. And remember, that 4 less, or that minus 4, has to come at the end. And now Bob has 6 more cars than Tim does. Well, if Tim has x and Bob has 6 more, that would be x plus 6. Now we just have to look at the sentence that starts to talk about the equation, which starts with all together. All together there means that you're doing addition. You're adding all of them together. So Tim plus Joe, plus Bob is equal to 9 more than 3 times as many cars as Tim had by himself. 9 more, that's that plus 9, 3 times as many as Tim. Now we just fill in the expressions we used. T stood for Tim, so Tim is X. J is Joe, so Joe is that entire 2x minus 4. Bob is x plus 6. And then here, 3, remember Tim was x, so I'm replacing T with x, plus 9, and there you go. You have that equation set up, you have the expressions. You did not have to solve it because that's what the directions said. So take a look at your homework problems and make sure you submit them.